Hello dear students, welcome to GATE Wallah English, the channel which is dedicated to all our English speaking students, and this is another lecture of engineering mechanics. This is lecture number 3, and in today's lecture we are going to learn about moments. In last lecture we talked about forces, we learned the basic concepts of forces, we understood the definition of force, we understood concepts related to force, and in today's lecture we are going to talk about moment. Okay, so let's begin this lecture without any delay. Now first of all we are going to go through the last lecture's content for a quick revision. So in the last lecture I told you the definition of a force. I told you what exactly is a force, what do we mean by a force. So force is what? It is the interaction between two bodies. We talked about this yesterday in great detail, that every member of a machine or a structure is connected to several other members. All these members are applying force to each other. What does this mean? They are actually interacting to each other. They are pulling each other, pushing each other, and this pulling, pushing, rubbing is denoted by force. So force is a way of showing the interaction between two bodies, right? And it is the action of one body on another body that tries to change the motion of the other body. Tries to change means it is not necessary that the motion will change, but it will try to change that. Then after that we talked about principle of transmissibility. What is principle of transmissibility? You can move the point of application of a force along its line of action anywhere without changing any external effect. In engineering mechanics, we only find the external effect of force. External effect means whatever effect we can watch from outside the body, okay? Whatever is visible outside, from outside, displacement, velocity, acceleration, all these are external effect of the force. So if I move the force anywhere along the line of action, then the external effect is not going to change. Now today I am going to tell you the significance of this. Today I am going to explain how this principle of transmissibility is actually used in question, okay? And then we saw the vector addition of two forces, for which we use parallelogram law. What is parallelogram law? If the two forces are like two sides of a parallelogram, then the diagonal of this parallelogram is the resultant, and we found out a formula of the resultant. Now I gave you a question on the basis of resolution of a force. This was your assignment. I hope that you guys have solved this question. To study the effect of 2 kilonewton tensile force in cable on the beam, it is replaced by its equivalent of two forces at A, Ft parallel and Fn perpendicular to the beam. Magnitude of Ft and Fn are, okay. So what we need to do is, we need to resolve the force parallel to the beam and perpendicular to the beam. Whatever force we will get parallel to the beam will be the tangential force, and perpendicular to the beam will be the normal force, right? So this is Ft and this is Fn. Yes, Ft parallel and Fn perpendicular to the beam. Okay, now we need to find the values of Ft and Fn. So how we are going to do that? In order to find Ft and Fn, we need to find the angle between 2 kilonewton and any one of these forces. Okay, now look at this angle. This angle is 30 degree, means this angle is 30 degree, and this angle is 20 degree. So what will be this angle? The angle between Ft and 2 kilonewton, it is going to be 50 degree. So we have the angle between the tangential force and 2 kilonewton. So now we can find Ft. What will be Ft? As it is making the angle with 2 kilonewton, it will be the cos component. So it will be 2 cos 50. And Fn will be the sine component, so it will be 2 sine 50. So 2 cos 50 is 1.2 1.28 kilonewton, roughly 1.28 kilonewton, and 2 sine 50 is 1.53 kilonewton. So Ft and Fn are 1.28 and 1.53 kilonewton, which is the option D. So this was the assignment question of the last class. Now let's move on with today's class. So today we are going to learn moment of a force, moment of a couple, and also Varignon's theorem, which is a very important theorem related to finding the moment. And we are going to solve a lot of questions related to moment. And let me tell you that whatever we are going to solve today, you might get a question like this in next exam, in your next year GATE exam. Okay, you might be thinking whether they give you questions like this, calculating moment. Do they have these type of questions in GATE? Yes. In fact, this year in GATE XC, there was one question of calculating moment. So it is very important to understand these very basic concepts. Now let's begin this lecture. So let's understand what is moment. Moment means what? It is the tendency of a force to rotate a body. Let's say that this is a body. I am applying two forces along the axis of this body. So you will see that these forces do not have any tendency to rotate this body. But if I apply a force like this, then you can see that this force will try to rotate this body, right? So this force is actually applying moment on this body. Moment of a force is the tendency of the force to rotate a body about an axis. In this example, you can see that we are trying to rotate this, body about this axis. And in order to do that, I am applying a force here. So this will generate a moment which will rotate the body. Now it is important to quantify this. Quantify means what? We know that the force is trying to rotate this body, but how much is it trying to rotate the body? Is it trying to rotate it too much, or is it just trying to rotate it? How much is it trying? So that quantity is known as the moment. So what is moment? Moment of a force is the measure of the tendency of the force to rotate a rigid body about a fixed axis. How much this force is trying to rotate the body about the axis, that is moment. Now moment can be calculated in two ways. There is a scalar way of calculating moment and there is a vector way of calculating the moment. I will tell you the vector way of calculation later because you might get confused a little bit. So right now we will focus on the scalar calculation. So we can calculate the moment of a force in two ways. There is a scalar calculation, there is a vector calculation. So first we will focus on the scalar calculation. So I will tell you how we can calculate the moment of this force. So let's say that this is a rigid body. One moment. Let's say that this is a rigid body. Okay. And this is a force acting on the body. This is the line of action of the force. Okay. Now I want to find how much this force is trying to rotate this body about a particular point. Let's say I want to find the moment about this point O. So how do we calculate that? We are going to first measure the perpendicular distance of this point O from this line of action. Perpendicular distance means the minimum distance of point O from this line of action F. So let's say that this is a perpendicular from point O on this. I have drawn a perpendicular from point O on the line of action of the force, and let's say this distance is equal to d. So moment of this force M about point O is equal to F into d, where d is what? D is the perpendicular distance of F from point O. So this is the scalar formulation of the moment of a force about any point. If you want to calculate the moment of a force F about any point O, what you need to do? M will be equal to F multiplied by perpendicular distance. Now this moment can be clockwise or anti-clockwise. Right now, if I ask you what is the direction of this moment, whether it is clockwise or anti-clockwise, then what will you say? The force is applying an anti-clockwise moment about point O, right? This is acting anti-clockwise. Now how do we find the sense? A lot of people get confused how to find the sense of the moment, whether it is clockwise or anti-clockwise. There is for some people it is difficult to imagine, right? So let's understand how we can find out whether the moment is anti-clockwise or clockwise. Let's say you want to find the sense of the moment of this force F about this point O. So what you need to do is you put the thumb at point O and then you put the finger in the direction of force F. Okay, you put the thumb at point O and then you show the finger in the direction of F and you move the finger in the direction of F. So how is it rotating? How is it rotating? It is rotating like this. So it is anti-clockwise. So put the thumb at point O, show the finger towards the force F, okay, and then move the finger in the direction of the force like this. So it is applying an anti-clockwise moment, okay. So this is scalar formulation of the moment. Now what do we mean by a couple? You will come across this term a lot, couple. Now what do we mean by a couple? So a couple is defined as two parallel forces that have same magnitude but opposite directions and they are separated by a perpendicular distance. For example, let's say that this is a rigid body, okay, and this rigid body is subjected to two forces. Let's say there is a force F like this and there is a force F like this. Both are equal and opposite. This is F, this is F. Both are equal and opposite. Both have the same magnitude, same direction, but they are opposite. Same direction means their line of action is actually parallel to each other, okay, and they are separated by a perpendicular distance. Let's say this perpendicular distance is d. So this line is perpendicular to this force, it is also perpendicular to this force, and it is equal to d. So now what happens? Understand, this force F and this force F, they both will cancel each other because they are equal and opposite, right? It is acting like this, it is acting like this, so they are equal and opposite, so they both are going to cancel each other, but they will have a tendency to rotate this body. So what happens is both these forces get cancelled and we get a couple. And the value of this couple M will be equal to F multiplied by D. So what is moment of a couple and how is it different from moment of a force? When we say moment of a force, then this force has a tendency to translate this body as well as rotate this body. What is translation, beta? When a body moves like this is known as translation, and when a body moves like this is known as rotation. So if you apply a force, this force has a tendency to translate this body as well as rotate this body. Moment of a force is trying to rotate this body. But when we say there is a couple, then there is no translation, there is pure rotation, because both these forces got cancelled. This force and this force, they got cancelled. So now there is no tendency to translate, there is pure rotational motion, right? For example, if this is a body, if I apply a force like this and a force like this, then they will start rotating this body, right? They will start rotating this body. And this will be a pure rotational motion, right? So this is known as what? This is known as a couple. What is the example of applying a couple? Moving steering wheel of a car. When we move steering wheel of a car, we are actually applying a couple. We apply equal and opposite forces which form a couple. So steering wheel has pure rotational motion. Okay. So this is a couple. I hope you understood the example. So beta, moment of a force means the force has tendency to translate as well as rotate. It is also trying to rotate, it is also trying to translate. But when we say couple, then the translation is cancelled, forces are cancelled, we are getting pure moment M. Okay, chalo. Now let's move on to another very important topic. Yesterday I told you that we can break a force into two force components. Now today I will tell you another way of resolving a force. Yesterday we saw that we can resolve a force into two components, two mutually perpendicular components, right? Usually Fx and Fy. Now today I will tell you we can also resolve a force into a force and a couple. Now how do we do that? Let's understand. So let's say that we have a body, a rigid body, okay, and it is subjected to a force F at point A. This is point A, okay. Now there is another point at a distance L from point A, and I want to resolve this force into a force and a couple at point B. Or in other words, I can also say that I want to transfer the force F at point B. It is also known as transferring the force, okay. You can say that we are resolving the force F from point A to point B, or we can also say that we are transferring the force F from point A to point B. So how do we transfer the force from A to B? Let's understand that. So let's say this is the body, this is point A, this is point B, distance between them is L. Right now the force F is acting at A. This is the force F which is acting at A. So what I want you to do is apply equal and opposite forces at point B. I want you to apply equal and opposite forces at point B, like this. Now understand this. When I apply equal and opposite forces like this, they are cancelling each other. So I am not disturbing the effect of this force on the body. It will have the same effect. It will have the same effect. Right now also it has the same effect. Why? See, here there was a force F at point A and there was no force at point B, right? Now also there is a force F at point A and there will be no force at point B because they will cancel each other, na? So I am not disturbing the effect of the force on the body. The effect will still remain the same. Now what I want you to do is, this force and this force, we can remove these two forces and we can put a couple in place of these forces. So this is point A, this is point B, distance between them is L. So now what I have done is, I have removed the two forces which I have marked. I have removed this force and this force, and now I have made a couple. And what will be the value of this couple? Force F multiplied by the perpendicular distance between them, which is L. So you can see that I have transferred the force from point A to point B. So when you transfer a force from point A to point B, what do you get? You get a force and you get a couple. When you transfer a force from one point to another point, you get a force and you get a couple. Now beta, understand this, you are going to get direct questions based on this concept, okay? There have been questions in GATE exam where they ask you to transfer a force from one point to another point, okay? And you will also use this concept in questions, in solving some other questions. You will transfer force from one point to another point. You will use this concept in other subjects also. For example, in strength of materials also, you will see how we use this concept of transferring the forces, okay? So remember this concept. What is this concept? You are transferring force from one point to another point. So you get a force as well as a couple, okay? So we transferred force from point A to point B. Interesting concept, isn't it? Now let's move on to another concept, a very important concept related to moment, which is known as Varignon's theorem. And let me tell you, we are going to use this concept in the calculation of the moment. We are going to use this a lot. So let's understand what is Varignon's theorem. According to Varignon's theorem, moment of a force about a point is equal to the sum of the moments of the components of that force. Now it is hard to understand from this statement, so I will just give you an example, okay? Let's say that we have a rigid body like this, okay? Let's say that there is a force acting like this. Let's say this force is F and it is acting at this point, and I want to find the moment about this point A. Now I know this distance. Let's say this is 4 meters, and I know this distance. Let's say this is 3 meters. Okay, and I want to calculate the moment of this force, okay? Let me make it like this. Okay. F. Now, according to the scalar formulation of the force, in order to calculate the moment of F at point A, I need the perpendicular distance, right? So this is the line of action of the force. This is the line of action of the force, and this is the perpendicular distance, D. But the problem is we don't know the value of D, and it is very difficult to calculate this D. Okay, even if I give you the angle of this force, even if I give you this angle, let's say that this angle is 30 degree. Okay, even if I give you the angle 30 degree, it is very difficult to solve this geometry and find this D. So in these problems we use Varignon's theorem. Now what Varignon's theorem says it, you just resolve this force into two components. So what will be this component? It will be F cos 30, and what will be this component? It will be F sin 30. So what I have done is I have resolved the force into two components. Now instead of calculating the moment of F, I will calculate the moment of F cos 30 and F sin 30, and I will add them, and I will get the moment of F. So according to Varignon's theorem, moment about A of this force will be equal to F into D. Now beta, whether it will be clockwise or anti-clockwise. So what did I tell you? How we will find the direction of moment? Put the thumb at point A and show the finger towards F. Move the finger in the direction of F. So you are getting a clockwise moment, right? So this is clockwise. Okay, this is clockwise. Now understand this. I am not able to find the moment like this. So what I will do is, I will calculate moment of the components of this force and I will add them. Now F cos 30, put the finger at point A, put the thumb at point A, show the finger towards F cos 30, move the finger in the direction of F cos 30. It is applying clockwise moment, right? This is also clockwise and the moment of F cos 30 is also clockwise. So I will take it positive. So what will be the moment of F cos 30 beta? F cos 30 multiplied by this distance, 4 meter, right? Now, what will be the direction of moment of this force? Put the thumb at A. Now, show the finger towards the force and move the finger in the direction of the force. So it is applying anti-clockwise moment. So I will take it negative, okay? So minus F sin 30 multiplied by, what is the distance? 3. So according to Varignon's theorem, if you can't find the perpendicular distance of the force, you just resolve the force into components and you calculate the moment of the components. So moment of a force about a point is equal to the sum of the moments of the components of that force about the same point. Moment of F about A is equal to the sum of moment of components of F about A. So I hope this Varignon's theorem is clear to each one of you, right? It was difficult to find this distance D, but it was easy to find the distance of F cos 30 and F sin 30 from point A. So we calculated the moment of the components. Instead of calculating the moment of the force, we calculated the moment of the components. Okay. So this is known as Varignon's theorem. Okay. Chalo. So let's solve a few problems based on this theorem, because we will use this theorem in calculating the moment. in almost 90% questions, you will use Varignon's theorem in order to calculate the moment. Okay, so let's solve this first problem. Moment of force F about point A is. So you can see that we have a force F acting at point B. This is the line of action of the force, and we need to calculate the moment at point A. Now I will tell you the significance of principle of transmissibility in this particular problem. Okay, now first of all, let's resolve this force into two components. But in order to do that, we need the angle of the force, right? So how do we find the angle, beta? Understand, because you will see a lot of these type of triangles in engineering mechanics. So how to find the angles in these cases? Understand this. So we have this triangle, right? They have given you this type of triangle, and they have given you this 3, this is 4, and this is 5. And let's say this is the angle theta, horizontal angle theta. Okay. Now beta, from this triangle, what will be sine theta? Sine theta is what? Sine theta is perpendicular by hypotenuse. So it will be 3 by 5. And what will be cos theta? It will be base upon hypotenuse, means 4 by 5. So you have these type of triangles in order to calculate sine theta and cos theta easily. Okay. So sine theta is 3 by 5, cos theta is 4 by 5. Okay. So now we can resolve this force into two components. So if I resolve this force into two components, let's say this is our theta. So this will be your F cos theta, means 1000 cos theta, and this will be your 1000 sin theta, right? Now let's find out the moment of these two components at point A. We are going to apply the Varignon's theorem. We have resolved the force into two components and we are going to use the Varignon's theorem. So moment at point A will be equal to how much? This 1000 sin theta is going to apply a clockwise moment and 1000 cos theta is going to apply anti-clockwise moment. Now which one to take positive and which one to take negative? There is no universal law. You can take any one positive, any one negative. Okay. So what I am going to do is I am going to consider this anti-clockwise moment positive. Okay. So 1000 cos theta multiplied by, what is this distance beta? Each block is of 30 mm. So 30, 30, 30, 30, 30, 30. 1, 2, 3, 4, 5, 6. So 1000 cos theta into 180 mm, and this is positive, minus 1000 sin theta into 1, 2, 3, 4, 120. So what will be the moment at point A? What is the value of cos theta beta? 4 by 5 into 180 minus value of sin theta is 3 by 5 into 120. So moment at point A will be how much? I am getting 72,000 Newton mm, but they have asked you to calculate the moment in Newton meter. So convert mm into meter. So we are going to divide this by 1000, right? 1 mm is 10 to the power minus 3 meter. So it will be 72 Newton meter. This is our answer. 72 Newton meter. Very good, very good, very good beta. Now I will tell you a very interesting concept. Now understand this concept. Right now, we have resolved the forces at point B, right? But I can apply principle of transmissibility here. Let's move the force from point B to point C, because this is the line of action, right? So let's move the force from point B to point C. So this is your F. And now let's resolve the force into two components. So this is angle theta, right? So this will be 1000 cos theta, this will be 1000 sin theta. Now understand, we have applied principle of transmissibility, and according to principle of transmissibility, the net external effect should not change. The moment is also an external effect. It is trying to rotate the body. You can watch it from outside, na? How the body is rotating. So moment is an external effect. So according to this theorem, moment should not change. We should still get this moment, 72 Newton meter. Let's see whether we get it or not. So in this case, if I calculate the moment at point A, you can see that 1000 sin theta is passing through point A. So its distance from point A is 0. So it will not apply any moment at point A. It is passing through point A, so it will not apply any moment at point A. I will only get the moment of 1000 cos theta, right? So it will be 1000 cos theta multiplied by, what is this distance? 1, 2, 3 means 90. And what is the value of cos theta, beta? 4 by 5. So what will be MA? We are getting 72,000 Newton mm or 72 Newton meter. So we are getting the same value. Can you see that? 72 Newton meter. So this is the application of principle of transmissibility. Do you understand it now? Do you understand it now? So instead of resolving it at point B, we resolved it at point C. We moved the force from B to C and we resolved the force at point C. Now we can further move the force from B to D. So this time I want you to resolve the force at point D. This is our force F. This is angle theta. So this time I have moved the force from B to D. So this will be F cos theta. This will be F sin theta. Now understand this. F cos theta is passing through A. So its moment will be 0. I will get the moment of F sin theta only. And this moment will be anti-clockwise. See, this moment was also anti-clockwise. This moment is also anti-clockwise only. So it will be 1000 sin theta multiplied by 1, 2, 3, 4. So 120. 4 into 30, 120. And what is sin theta? It is 3 by 5. Okay. So 3000 into 120 divided by 5. I am still getting the same value. 72,000 Newton mm. Or 72 Newton meter. So did you understand the concept of principle of transmissibility here? Did you understand the beautiful concept of principle of transmissibility? It doesn't matter whether I resolve the force at point B or point C or point D, I am getting the same moment. Now beta, in which case the calculation was easier? In the first case or second case or third case? You would say that in the second and third case it was easier because one of the force component was passing through A. So our calculation became easier, right? In the first case, when we were resolving it at point B, then we were getting the moment of this as well as this. But in the second and third case, we were getting the moment of only one component. So you can use this principle of transmissibility in order to reduce your calculation. So I hope that you understood something new here. Even if you have studied principle of transmissibility as well as Varignon's theorem, I hope that this is something new for you. Yes? Chalo. So we can use principle of transmissibility in order to reduce our calculation. Okay. Chalo. So let's move on to the next question and we will solve this one. Solve this one. I want you to solve this one on your own. The magnitude of moment of 600 Newton force about point O is. Magnitude of moment of 600 Newton force about point O is. So we need to find the magnitude of this moment of this force about this point O. So apply the Varignon's theorem and calculate the moment. Now here beta, don't try to use principle of transmissibility, because if we move the force here, we will get only one component, but we will then have to calculate this distance. We will then have to calculate this distance. Although it is easy to calculate, but why bothering doing that? Just calculate the moment at this point only. Okay, resolve the force here only. You have this distance as well as this distance, so resolve the force here only. So if I resolve the 600 Newton force into two components, this component will be the cos component because it is making the angle with the force. So 600 cos 40 and 600 sin 40. Now if you are confused about the direction of moment, clockwise, anti-clockwise, put your thumb at point O, point the finger towards the force. So 600 cos 40, I am pointing it towards the force 600 cos 40 and move it in the direction of 600 cos 40. So see, it is applying clockwise moment. Similarly, put the thumb at point O, show the finger towards 600 sin 40, move it in the direction of the force. Yes, again it is applying clockwise moment, right? Chalo. I am glad beta that you have mastered engineering mechanics. I want all my students to become like that. Chalo. So both the moments will be clockwise only. So moment at point O will be equal to how much? 600 sin 40 multiplied by the distance 2 meter. Then 600 cos 40 multiplied by the distance 4 meter. Even if you have studied engineering mechanics, you can use this course as a revision course. Okay. So we are getting total moment as 2609.85 Newton meter, right? The force was in Newton, the distance was in meter. But we need to calculate it in kilonewton meter. It is very important that you calculate it in the unit mentioned in the question. Okay. So 2.609 kilonewton meter. 2.609 kilonewton meter. Are you getting this much? 2.609 kilonewton meter. Yes. Chalo. Now let's calculate the moment of the moment of force about point O is. Chalo. So now in order to calculate the moment of this force, again we are going to resolve it. So if I resolve it, I will get two components. One like this and one like this. Okay. Now let's say the force is making angle theta with horizontal. Again we have these triangles. Okay. Again we have these triangles. So if this is the angle theta, you know that sine theta will be 3 by 5, cos theta will be 4 by 5, right? So this one is making the angle, so it will be 100 cos theta, and this one will be 100 sine theta. Both of them will make clockwise moment at point 2, right? Both of them will have clockwise moment. This will also have clockwise moment, this will also have clockwise moment. So M at point O will be how much? 100 sine theta multiplied by 5 plus 100 cos theta multiplied by 2. Sine theta is 3 by 5. And cos theta is 4 by 5. So how much are you getting? 460 Newton meter, right? And they are asking us to calculate the moment in Newton meter only. So it is 460 Newton meter. Very good, excellent. So moment of the force 100 Newton about point O is 460 Newton meter. They are only asking us about the magnitude, but if they ask us about the direction, then it is clockwise. This moment is also clockwise, this moment is also clockwise. So this is a clockwise moment, right? Chalo. Now let's solve this one. Magnitude of the moment of 600 Newton force about point A is. Let's solve this one. So in this case, first we will resolve the force into two components. So let's resolve the force into two components, this and this. Now look at this angle. What will be this angle? 45 degree, right? This is making 45 degree with horizontal. This angle is 45 degree and this angle is 90 degree. So this angle will be 45 degree. This angle is 45 degree. So this is 30 cos 45 and this is 30 sin 45. Now we need to know the distance of 30 cos 45 and 30 sin 45 from point A. So this is the perpendicular distance of 30 cos 45 from point A. What will be this much? What will be this distance? What will be this distance? So I can divide it into 2. I can divide this distance into 2. This is 1.6 meter and this angle is also 45 degree. This is 1.6 meter and this angle is 45 degrees. So what will be this distance? 1.6 cos 45 and this will be 1.6 sin 45, right? This will be 1.6 sin 45 and this distance will be 1.6 cos 45. So now we have the distance of 30 cos 45 from point A. And this moment will be clockwise. Moment of 30 sin 45 is also clockwise. So 30 cos 45 multiplied by, what is this total distance beta? 1.6 sin 45 plus 1.6. Then moment of 30 sin 45. This will also be clockwise. And what is this distance from point A? 1.6 cos 45. So from here you are going to get the moment in Newton meter. So how much is it? It is 81.94 Newton meter. Are you getting this much? 81.94 Newton meter. So in this case, we had to resolve the force as well as find the distances, right? Here the challenge was to find the distances. So 81.94 Newton meter is the moment of the force 30 Newton about point A. So these were the scalar calculations of the moment. But in some cases you might find the vector calculation of the moment. So how do we calculate the moment? By vector formulation. Let's understand that. Okay. So in case of vector formulation, you will get some questions like this. Let's say that we have a force F. Let's say we have a force F. And this force F is at a distance from point O. Now in case of vectors, in order to denote the position of a vector from some origin, we use position vectors. Now what do we mean by position vectors? Understand it. Okay. Let's say this is a body and there is a force F like this. And we need to calculate the moment of this force about some point. Let's say this is the point O. So if I draw a vector from point O to point F, it is known as a position vector. And you can draw this vector anywhere. You can draw it here, you can draw it here, you can draw it here. You can draw this vector anywhere, beta. Okay, it is not necessary that you need to draw it at a particular point. You can draw it anywhere. Okay, you can take any point on this force and you can draw the vector. This is known as the position vector. This is R. So R is what? R is known as position vector. Okay. How to find the position vector? That I will tell you through example. When I solve an example, then you will understand how we can find the position vector. But again I will repeat that this position vector, it is not necessary that it should point here. It can also be here, it can also be here, it can also be here, anywhere. Okay, so it is a vector drawn from the point to this vector, force vector. Now the moment m of the force about point O is actually the cross product of the position vector and the force vector. The moment m is the cross product of the position vector and the force vector. So m is r cross f. Now you might be wondering, what is this? How do we find the cross product of two vectors? So let's understand through an example. Okay, let's understand through an example. Find the moment about the point I plus 2j plus 3k of a force represented by I plus j plus k acting through the point minus 2i plus 3j plus k. Let's understand how we can find the moment vector of this force I plus j plus k, which is acting at a point minus 2i plus 3j plus k about the point I plus 2j plus 3k. So understand this. The force right now is acting through this point. For example, here, this is the point. The force is acting through this point. So we know the coordinates of this point. And we want to calculate the moment at this point. So what are the coordinates of this point? I plus 2j plus 3k. So from this and this, we will first find the position vector. So the moment is, force is passing through this point and we need to find the moment at this point. So from this point to this point, we will first find a position vector. How do we calculate the position vector? Let's understand. This is the position vector of the force. Okay, how to find the position vector? So position vector r will be equal to, the force is acting at this point, right? Minus 2i plus 3j plus k, and we need to find the moment at this point, I plus 2j plus 3k. So it will be minus 2i plus 3j plus k minus I plus 2j plus 3k. So what will be the position vector now? It will become minus 3i plus j minus 2k. So we have got the position vector minus 3i plus j minus 2k. Now we need to calculate the moment vector. Okay. So how do we find the moment vector? Moment m is equal to r cross f. M is also a vector, r is also a vector, f is also a vector. So m is equal to minus 3i, this is the position vector, plus j minus 2k multiplied by, what is the force vector? I plus j plus k. So now we need to find the cross product of these two vectors. Understand very carefully how to find the cross product of two vectors. Okay. So in order to find the cross product of two vectors, we will write it like this: I, j, k. Now first write r. So it will be minus 3 plus 1 minus 2. This is the position vector, minus 3i plus j minus 2k, minus 3i plus j minus 2k. Then you write the force vector 1 1 1. Now you need to find the determinant of this. Now, do you know how to find the determinant of this? Do you know how to find the determinant? What you need to do is I, then multiplied by this into this minus this into this. So it will be 1 into 1 minus 2 into 1. Okay. So I 1 into 1 minus 2 into 1. Okay. Then minus j. I then minus j. Now again hide this. Minus 3 into 1 minus 2 into 1. Then plus k. Now hide this and this. Minus 3 into 1 minus 1 into 1. So I hope you understand how to find the cross product. I, j, k, then we wrote minus 3, 1, minus 2, then we wrote 1, 1, 1, and then we found out the determinant of this matrix. Okay. So m will be equal to how much? This will become 1 plus 2 means 3i. Then minus 3 plus 2 minus 1, minus 3 plus 2 minus 1, so this will become plus j. Then minus 3 minus 1 means minus 4k. So 3i plus j minus 4k. 3i plus j minus 4k. So this is the answer. C is the answer. So this is the moment vector. Okay. Now let's say I want to find the magnitude of m. This is the vector, na? So if I want to find magnitude of m, then what I will do, beta? How to find the magnitude of a vector? Root over 3 square plus 1 square plus minus 4 square. Root over this ka square plus this ka square plus this ka square. Okay. So you will find the magnitude of m. So it is 5.1. They have not mentioned the units. So it is 5.1. Okay. So right now they were just asking us the moment vector, but if they ask you to magnitude of moment, you can also calculate it like this. Okay. Let's solve another one in order to understand. The moment of a force F equals to 3I minus j plus 2k kilonewton passing through point 41 minus 2 meter about 0.204 meter is. Now this time they are asking us to find the magnitude. Okay. So how do we calculate it? First we find the position vector. So how to find the position vector, beta? It is passing through which point? 41 minus 2, right? And we need to calculate the moment about which point? 204, right? So see what we need to do. It was passing through this point and we need to calculate the moment at this point. So this minus this. So passing through which point? 41 minus 2, na? So I will write it 4i plus j minus 2k minus, we need to calculate the moment at this point, 204. So 2i plus 4k. So what will be the position vector, beta? 4i minus 2i. It will be 2i plus j minus 6k. So we have got the position vector 2i plus j minus 6k. Okay. So passing through this point minus calculating moment at this point. Passing through this point minus calculating the moment at this point. Okay, so we have got the position vector. Now we need to find the moment vector. So in order to calculate moment vector, we are going to find the cross product R cross F. So what is R? 2i plus j minus 6k multiplied by, what is the force vector? 3i minus j plus 2k. Now how to find the cross product, beta? I, j, k. 2, 1 minus 6. 2, 1 minus 6. Then 3 minus 1, 2. 3 minus 1, 2. Now understand this if you have not understood last time. First, it will be I multiplied by, hide this and this, hide first row, first column. What do you have? 1 minus 6 minus 1, 2. So it will be this into this minus this into this into this minus this into this. So it will be 1 into 2 minus 6 into minus 1. 1 into 2 minus 6 into minus 1. Then minus j, not plus j, okay, minus j. Now hide this one and this one. Hide this one and this one. Hide this one and this one. So now you have got 2 minus 6, 3 and 2. So it will be 2 into 2 minus 6 into 3. 2 into 2 minus 6 into 3. Now plus k. I minus j plus k. Now this time hide this and this. Hide this and this. Hide this and this. What do you have? 2, 1, 3, minus 1. So 2 into minus 1, minus 1 into 3. So what do you have now? What will be the m vector? It will be 2 minus 6. So minus 4i, right? 2 and this will become minus plus 6. So 2 minus 6 minus 4i cap. Then 4 plus 18. 4 plus 18, 22j cap. Then minus 2 minus 3, minus 2 minus 3, minus 5k cap. Are you getting this much? Or have I made a mistake? 2 2 plus j minus 6k na, 3i plus minus j plus 2k, 2 1 minus 6 3 minus 1 2. So I will be 2 minus 6 minus 4 minus j 4 minus 18. Okay. Now we have got the moment vector. We need to find the magnitude. So it will be minus 4 ka square plus 22 ka square then minus 5 ka square. So how much is the magnitude of the moment? I am getting 22.91. Now the force vector was in kilonewton, right? The force vector was in kilonewton and the distance was in meter. So it will be in kilonewton meter. Okay, the force was in kilonewton and the distance was in meter, so it will be in kilonewton meter. So we are getting 22.91 kilonewton meter. So this is the vector formulation of a moment. Okay. So till now we have, I think, not got any question on vector formulation, but they might give you sometime you might get this question. Okay. Now I have a very interesting question as an assignment for you, and this is a challenge for you actually. Find the angle theta for which moment of the force F at point A is maximum. You have this force F, right? It is acting at an angle theta from horizontal. For what value of this theta the moment of this force will be maximum at point A? And this is a challenge for you. I want all of you to solve this problem, and tomorrow in the class we are going to discuss the solution of this problem. Okay, chalo. So thank you so much for attending, and tomorrow we are going to discuss the further concepts of engineering mechanics. So I will see you guys tomorrow at the same time. Bye bye, take care, good night.